Good morning, friends from San Diego. EveryStepCalculus.com, EveryStepPhysics.com. This is Tom. I'm going to help you with this trapezoidal rule now. This is another Sudoku problem from calculus, the math subject that answers nothing useful. We're going to do this one. I'm going to do the whole thing for you and show you how my programs are so fabulous for this kind of stuff. Otherwise, you can study it for hours and never know what really to do. Like, for instance, how does this help you here? You know, I mean, so you're going to put down all these people. This is a Yahoo problem, you know. And this kid wanted to know. He had 4 question marks here after it, saying, "Oh my God, I'm panicked. What do I even start? What do I do with this stuff?" You know. And there's no system to it. In other words, you really don't know what you're doing. There's a formula for the whole thing if you of course find it out, and I have to use that for my programs to you know, program the calculator. But anyways, we're going to do this one here. Let's do it. Let's go to the main menu here, and we're going to the main menu, and I'm going to go up with the cursor because I want to go to the trapezoid. It's a trapezoid problem, so we're going to go to the T section, which is closer to the bottom of the alphabet here. So we're going to go up here to TRA. Here it is here. I'm going to press enter, and we're going to enter our function. S, they use S. I have no idea why. A lot of books, a lot of professors use S here for the area. This is the area, which every integral is finding the area under a smooth curve. It better be smooth, and then you better have a limits on it, limits of integration, which is here to A and B. Okay. So you're always finding with an integral, you're always finding the area under a curve. Or if they use certain formulas, you can just find spheres of, you can find not areas, but I might find to say volumes. Okay, sorry, my mind went blank there for instance, for a second. So anyways, here's what you're trying to find. You're trying to prove that. Do the same thing that a definite integral will do in calculus. Okay, so we're going to enter the function here, which is pathetic x squared. Notice how all these functions are really simple, because that's all there is simple functions. You know, alpha x squared. Say okay. We're going to enter the range from alpha 0, which they give you, to alpha 2. Okay. Yep. Enter intervals. The interval is the 4 of them. Alpha 4. And here's the formula, trapezoidal rule formula. Okay, change of x divided by 2 times f of a. A is the lower limit, plus 2 times f of x1, plus 2 times f of x2, 2 times x3, x4, etc. And then you can go all the way up to how much you want. I only do 10 units here with my programs. You can do whatever you want, but at the end you put f and b in there, put those in there in that too, and b is the upper limit. Let's not talk about this baloney too much. Change of x, we do that, which is b minus a divided by n. Turns out to be 1/2. Great, we got that. We're going to compute the intervals. Okay, so x at 0 equals a equals 0. The lower limit is 0, so that goes here. x1 equals 0 plus 1/2 change of x times 1 equals 1/2. x2 equals 0 plus 1/2 times 2 equals 1, etc. Notice how many you go up to. This is a system. Now you can remember this, okay? So even if when my program, because I've programmed it, I find the system, the best system for this crap, and give it to you, so that even if you don't want to use the calculator in a test or something, you can at least try to remember something. Let's see now, x3, okay, we're going to put 0, which is a lower limit, plus 1/2, which is n, or the change of x, times third one, which is x3, equals 3/2, okay, etc. We got 4 of them, so we're done. We're going to place those into a function. F of x, x1 equals f of 1/2. So we put 1/2 in the function, compute it 1/4, etc. Put 1 into the function, compute it equals 1. 3/2 into it, 9/4, 2 into it for 4. So x is 4 is 4, okay? Here's the definite integral again, which is the only sane integral there is. Indefinite integral, which is just always a plus c after it. 10 million plus c's, constants that you're supposed to add to the integral after you compute it. And, you know, how do you find the extra constant, you know, in things? I don't know. So now we're going to do the formula for the approximation, which is change of x divided by 2 times f of a, etc. for 4 of these. 1, 2, 3, 4. At the end, notice the f of b. And we put them in here. We're going to multiply this, which is, you know, the 1/2 divided by 2, which is the new change of x here. And these are all we computed as you write everything you see on your paper, okay? And etc. Keep going. The answer is 11/4, 2.75 square units when you add them all together and multiply times the 1/4. So that's what he got here, right? This answer person. Not close to the real answer of 2.67, so let's go back and let's go to the main menu. Let's scroll down here to definite integral. So that's what you're asked for in the, and of course I do definite integrals all the way up to x, y, z. Here's just to the x one, so we're going to choose that one. Just as only got an x in the function. We're going to enter the function alpha x squared. Okay, I'll show you what you've answered. I'll show you what you entered so you can change it in case you made a mistake. I say it's okay. I'm going to enter the range. Alpha 0 and alpha 2. Looks good. We're going to integrate it. Just x cubed divided by 3. That's the integration of the x squared. At x equals 2, enter it in the function. Turns out to be 8/3. At x equals 0, upper minus lower. 8/3 minus 0 equals, the answer 8/3 equals 2.67 square units. He's put down 2.67. I like to rub it in that you've actually found the area of something, okay, as if that's so GD important in life, you know. I'm telling you, calculus should only be taught to math majors. Let them deal with it, not us. We're the sane people. They're crazy. Anyways, go to my site. Think about it. And one thing I want you to do, if you can, if you get this far, is to go over to the right corner there and subscribe. I need subscribers. I got to get to 1,000 subscribers so I can change and edit my videos, okay? So maybe you can help me on that, okay? And otherwise, go to my site, buy my programs, Calculus 1, Calculus 2-3, or Calculus 1-2-3. And, you know, all this is in the menu, like the back of a fabulous calculus book, and you'll have it for the rest of your life. Take your calculus book and throw it, burn it in 2 minutes after you buy my programs. You never use it again. But anyways, you have a good one with your and I'll help you all you can. I mean, you can email me and I'll help. Send me your tests. I'll show you how they work. I'll show you what you've answered in these tests, and you'll never fail another calculus test for the rest of your life as you buy my program. Never. Okay. And I could never pass a calculus test without my programs, and I've done it for 25 years, studied this stuff. All right, you have a good one. Good luck in your calculus.